Okay, what we're going to look at now is simplifying expressions and terms that have division in them. Okay, now if we simplify algebraic terms with division, so simplifying algebraic terms with division, uses the same steps as what we've done when we've simplified normal fractions. So uses the same steps as simplifying normal fractions. So we have discussed up until now that you guys are now treating fractions as something divided by something. And when we write a division term, so for example, when we write 3 divided by 4, we no longer write it like this. Instead, we're writing as 3 over 4. We write this as a fraction. These mean the same thing. Okay, so when we have algebraic terms that have division in them, we can actually treat them the same way as a normal fraction. Okay, so again, we have some steps that we would like you guys to take in order to do this. The first step is to write the terms as their factors. Okay, now what do I mean by that? When I say write the terms as their factors, what are factors? Okay, so if you go back to when we did fractions, you'll remember that factors mean something times something. Okay, so the factors of 12, for example, are 1 times 12, so 1 and 12 are 2 factors. 3 times 4 gives you 12, so 3 and 4 are 12. So with 12, we have 1 and 12. You can have 3 times 4. Okay, you can also have 2 times 6. So this is a list of the factors of 12. So the first thing we're going to do when we simplify an algebraic term with division is we're going to write the terms as a product of their factors. Okay, now the second step is that we cross out numbers or variables that are on the top and the bottom. Of the fraction. Okay, so what this means is if you have something that appears in both the numerator and the denominator, we're going to cancel those out. The reason we can do this is, for example, let's say that we looked at 12 and we said 12 is 3 times 4. Okay, so we'll say we had 12 over 16. 12 is, let's make it over 20 instead. 12 is 3 times 4, and 20 is 5 times 4. Now you can see we've written it as its factors. We can now cross out numbers or variables that are at both the top and the bottom. We can cross out this 4 by 4 and 4 because 4 divided by 4 is the same as 1. Okay, we're actually replacing this with a 1, both top and bottom. It's just that we're a little bit lazy again as mathematicians, so we don't tend to do that. If we have 3 times 1, we just write it as 3. Okay, so 12 over 20 is the same as 3 over 5. Okay, so you can cancel out 2 factors that are at the top and the bottom as long as it's multiplied. Okay, so that only works if they're multiplied by something. We'll talk about that in a little bit more detail shortly. Okay, the next step is to check that there are no more factors. So maybe sometimes you've missed a factor. So when you chose your first factors, you missed something. Okay, so you just need to check that there's no more of them left. And then the last step, as with multiplication, was that you need to simplify your indices. Okay, particularly for the variables. Okay, so let's try this out. Let's do a few examples. Okay, I'll leave the steps on the screen here for you. So for example, let's say that we have 6m divided by 3. Okay, now 6 can be written as 2 times 3. We're going to write that as multiplied by m, and 3 is just a 3. Okay, you can write it as 3 times 1 if you want, but it's not necessary. Now you can see here that what we have is 3 over 3. Okay, those two are the same. 3 divided by 3 is the same as 1, so we can cross them out, replace them with 1s. Okay, and what we get left with here is just 2m. Okay, that's one example. Nice, fairly straightforward one. We're going to do some slightly harder ones as well. Okay, let's say that we have 12a squared b divided by 20ab. Now luckily we just did the 12 and the 20, so that one's pretty easy. We know that that's 3 times 4 times a times b, because a squared is a times a. Okay, 20 is 5 times 4 times a times b. Now with this one, you have to be a little more careful because we want to make sure that we don't cancel out too many terms here. Okay, so we have the 4 in both of them here. That's the first thing, so we're going to be able to cancel that out. In addition, we have an a and an a here. Okay, but now that a is gone, so we're not going to be able to cancel out the other a that's sitting there. Okay, and thirdly, we also have the b and the b here. So we're going to cancel out the 4s, we're going to cancel out the a's, and we're going to cancel out the b's. What we get left behind with is 3a in the numerator, and in the denominator we have 5. Okay, so 3a over 5 is our answer for this one. Alright, one more slightly harder one. Just going to take this over a little bit because I did it a little bit too far across. Okay, so one more slightly harder one. We're going to do 36d squared e divided by 42d e cubed. Okay, so let's look at 36 and 42 first of all. So 36, and this one's a bit harder because we've got bigger numbers, but 36, pretty easy. We'll go with 6. Whoops, that's not a 6, that's a 3. We'll go with 6 times 6. Okay, d squared is just d times e. Okay, and in the denominator we have 42, which we've already divided by 6 up the top, so we need 7 times 6 here. Okay, times. We have 1d, and we have 3 e's. 1, 2, 3. Okay, so now we can start with our cancelling again. Alright, we have the 6's that match here. We have one set of d's that matches here. And we have a set of e's that match. Okay, so they can all be cancelled. No more 6, no more d, no more e. And what we get left with is 6. And then there's 1d left on the top, divided by, there's a 7 on the bottom, and then we have 2 e's. So that's where we need to simplify the indices, because that's now e squared. Okay, so this is how we are going to work on simplifying things that are using division. Alright, there's one situation now where it becomes a little bit harder. As you can see, in all of these cases, everything is multiplied. Okay, so we just had one term on the top, one term in the numerator, one term in the denominator. So for example, with the 6m over 3, the first term is 6m, that's in the numerator. Okay, and in the denominator we just had 3. Alright, there's no pluses or minuses in any of these. When we have a plus or a minus, we have to treat them a little bit differently. Okay, so when there's an addition or subtraction, we firstly need to think about how this works. Okay, so if we have 2m plus 10 divided by 2, as an example, we can't just cancel the 2, okay, because you can see there's a 2 in both of them. However, then you've only divided the 2m by 2. You haven't also divided the 10 by 2. So when we have a plus or a minus, you need to make sure that whatever you cancel from everything in the top. So when we write this as our factors, 2m becomes 2 times m, 10 becomes 2 times 5, and then we have our 2 in the denominator. Okay, so you can see now that we have a 2 in all three positions here. We have the 2 in all three of them. If we're going to cancel, we need to actually cancel from all three terms. Okay, you cannot cancel if something only appears in one of the terms with the plus. So what we have in this case left is, at the top we have an m plus 5 divided by, oh, it's not divided by anything because that 2's gone. Okay, so our answer here is m plus 5. So let's do another one of these ones where it's a little bit harder. Okay, so let's say that we have 4p squared plus 12p divided by 4p. Okay, so let's have a think here about what we've got. We need to write these as their factors. So 4p squared is the same as 4 times p plus 12p is the same as 4 times 3 times p, and in our denominator we just have 4 times p. Okay, so here we can again look, and you need to think of things that are in all three terms here. So we have a 4 here, a 4 here, and a 4 here. That means those 4's can be cancelled. Alright, what we also have is a p in all three, and because it's in all three, the p can be cancelled. Alright, and what is left behind then is, in the top, in the numerator, we have a p plus 3, and that is everything. Okay, so you can only do this if you can find the what you're cancelling, what you're dividing by in all terms. Okay, you can't do this if it's only in one. Alright, it's a little bit more complicated, but I think you guys will be absolutely fine with it.